All right, so let's go ahead and talk about the information necessary to complete the first lab. We've got the reference sheet open and available here. I've got the images that we'll need, and also I pulled up a list of measurements that will be in the questions themselves. You don't have to be able to find this again separately, but it'll help us to talk about it if we can see them here. This first lab is really important because there are several concepts and definitions that we need now that we will need through basically most of the rest of the semester. Especially in a couple of weeks, we've got some labs coming up where we need to pay careful attention to some of what's going on here. So, a couple of these initial instructions, we need to understand that exact numbers are things that are going to be perfect, that can't have any error in them. So if you can count something, you can point at one at a time different objects, or in this case, people. It talks about students in the example here, or something else that is definitely true. So a conversion like 12 inches in a foot, 1 inch is 2.54 centimeters. There's 100 centimeters in a meter. Those are things that are all perfectly true, so they're considered exact numbers. Anything that we would take in the lab room, though, would be an approximate number. So you always have to guess a little bit whenever you're measuring something. And there's always some way to measure better, and that's something to keep in mind that might help you set that definition. Okay, then we need a couple of vocabulary words here. So we need to understand that accuracy means the number of significant digits in a measurement. So there are some rules for significant digits we'll talk about in a minute. Precision is basically the placement of the last significant digit. So often it's just how many decimal places are in some measurement. The rules for significant digits can be a little bit tricky. The first one's easy. Anything that's not a zero definitely counts. And then after that, unfortunately, gets a little trickier. So the zeros can count or not count in several cases. The main one that seems to trip up students is rule number 4. So any zero that's at the end of a decimal place, so like here, this 14.0, that zero is somewhere after other significant digits and after a decimal place. That's different than the zeros that we see in this example. Those zeros are after a decimal place, but they're not after a significant digit. So the zero up top counts, but these zeros down the bottom don't. They're called leading zeros, and they're usually pretty easy to spot. So that follows rule number 6. If you have some tiny measurement, basically you don't count any significant digits until you get to the first number that's not a zero. We don't use this super often in this class, but if you have very large numbers, the zeros at the end, notice there's no decimal place here at all. The zeros at the end don't count unless they've been specifically marked. So the bar or the tag that's at the top will mark the last significant digit. Okay, and so having those definitions at our disposal, we can move on to see how things are measured. So this would be an unusual type of tool, but we have apparently a yardstick that has inches on it. That's not the part that's weird, but we want to measure in one decimal place in inches, and that's the part that is strange. So normally, if you've used a ruler or a tape measure, we would tend to use fractions along with inches. So this is strange, and after this example, we will never use this again. But it was just meant to show that basically you always read a step further than what you can clearly see. When we look at letter A, this is clearly between the number 5 and the number 6. And so because we try to say how far between the numbers it would be, then we want to guess. The halfway point would be somewhere maybe here. And so, this is what it would be for 5.5. And we notice that A is a little bit less than that. So then this could be something like 5.4 or 5.3. It's your best guess for how much less than 5.5 that would be. Then if we look at letter B is clearly between 7 and 8. If we think about where the halfway point would be, somewhere about here, so that would be 7.5. And clearly it's more than that, right? And it seems like it's not too far off of the 8. So maybe this could be 7.7, 7.8, 7.9, somewhere in that range. And then we see C. This one is almost right on the 9. 9.5, I'm not sure is even shown here, but just a hair past where the 9 is. So, maybe that's something like 9.1. Now, we've talked about the numbers on all of these, and I've written them down, at least are reference points. I'm not trying to give any direct answers away, but you do want to keep in mind that all of the measurements that come for this are measured in inches. So anything that you record from this measuring device will have one decimal place and inches. So that's marked here, it's referenced here. So, those clues. And then it gives you, again, down here, that information. So if you're using this paper to write through, then you can list those, and that'll help you with your lab quiz for later. Now, what we're actually going to see when we measure things in the lab, we're going to see on rulers and meter sticks and on triple beam balances, we're going to see things that require 2 decimal places. So similar to before, we can see whole numbers, 1, 2, 3, 4, 5, and presumably there would have been more, but this was cut short. And then we see a bunch of additional lines. And what we want to think about now is that if we can see divisions between the numbers, and if we can count them, all right, there's 9 lines between here, and the 10th line is the next number, then each line is a decimal place, 1 decimal place. And so if we're looking at something like letter B, letter D, those two we can see are between the lines, and then that's our big clue that we want to go a step further. So we can read to the 100th place, basically 2 decimal places. It helps a lot of times to think about money with these, because money typically has 2 decimal places, and I think that might help you to see how to split these up. So the whole numbers would be like dollars. If it was a perfect $1, then we'd have 1.00. Keeping in mind that this is in centimeters, and the proper thing there would be 1.00 centimeters. Then if we split it another step, then each of the lines is like dimes, right? And so if we look at letter A, they give this one to us, but we want to confirm and make sure we get the same thing. The first line here would be like 1 dime, so that's 10 cents, 10 centimeters. Then the second one would be 20 cents. And I don't have enough room to write that on all of these, but we can easily count and get there. So the third line would be 30 cents or 0.30 centimeters. Then the fourth line would be 40 cents or 0.40 centimeters, which matches what we were told in the example. So if we look at letter B, then each line again is like a dime. So we start on $1 or 1.00 centimeters, then 1.10 centimeters, 1.20 centimeters, and so on and so on. If we look between these lines, that looks to be 1, 2, 3, 4, 5, 6, between the 5th and 6th lines. So think of a dollar amount between $1.50 and $1.60. Okay, and then you're guessing between those. And to me, it looks like it's a little bit past halfway. This may try to fix it and move. Yeah, I kind of missed anyway. I was trying to draw where the halfway point would be, and to me, B is a little bit past that. So, think of something that would be a dollar amount a little bit more than $1.55 or 1.55 centimeters. It'd be slightly past that. Now, C is a special case, and this is very uncommon, but C looks like it would actually be perfect. And so remember, we think of these lines as whole numbers, but we do have to remember that all of these require 2 decimal places. If you can measure 2 decimal places ever, you want to measure 2 decimal places always. So we would say that that's a perfect 3.00 centimeters. So that answer, I guess I did give it away, but it's directly on the line. The big thing I want you to remember from this is that it's very uncommon for measurements to end in zeros like this, and especially double zeros like that. But C is dead on right where the perfect 3 would be. If we look at letter D, between the 4 and 5, so again, this would be like 4.00 centimeters and 5.00 centimeters. Then counting lines is between the 3rd line and the 4th line, and it's somewhere around the middle of the 3rd line and 4th line. So some amount between 4.30 centimeters and 4.40 centimeters. So think about what that might be. It looks like it's reasonably close to half. So you can use that to help you make your guess. Okay, then we have rules for our measurements that we would take here in a hands-on physical lab. We have several different objects. There are different colored blocks. They're green and blue and red and orange, I think. Slightly different shapes. Most of them are boxy sort of prisms. A couple of them are triangular. Then we have some discs, which I do have a picture of, and the cylinders, which I again have a picture of. So if we scroll down and we pretend like we're doing the next part of the lab, then we need to take the description of the objects. We need to look at it. We need to give it a name. So we have the first one here is a cylinder, and this is the disc, but it's zoomed way in, hopefully to make this easier to see. And then I've also, on top of the picture, put a line on where it hits the ruler to make that a little bit easier to read. There are 2 different cylinders that I have in my set, 4 different discs, and what is that? 6, 7 different blocks. This particular cylinder was the second one, and so if we think about what these names are, if it's the second cylinder, then I think there's a fairly obvious name that we can pick for it. Okay, then once we have that name, we want to think about where the measurement would be. So it is zoomed in, and the light's a little bit funny here, and that unfortunately changed when I cropped the image. But we can see the whole number. If we think about money, this would be like 1.00 is here. So 1.00 centimeters is for that perfect line. The slightly longer line is halfway between 1 and 2. So this would be 1.50 centimeters. This line here would be 1.60 centimeters. Okay, so we're looking at some number that would be between these. Remember, we always want 2 decimal places and cm for centimeters on our measurements. The halfway point would be somewhere like here, and it does seem to be a bit past that. So keep that in mind when you make your guess for that measurement. If we look at the significant digits of that measurement, it's going to have a whole number and 2 decimal places that count. So, think about what that's going to mean for significant digits if we have 1, 2, 3 places that we're looking at. Okay, then we want to compare this to the measurement that was taken and given as the correct value. So each of these objects was measured with a caliper, which measures a lot better than a ruler, because a ruler is basically a stick with a bunch of lines on it, and the caliper can read out and give much better sorts of answers. So if we look it up, we decided this was cylinder B. So from our list, cylinder B, 1.586 centimeters. So again, I guess that's a given answer. So there's another free one. Okay, if we look at the number of significant digits in this one's nice because there are no zeros, so we just count all of our digits, 1, 2, 3, 4. In fact, almost all of these on this page have 4 significant digits. The only ones that don't are the discs, because they start with a 0, and none of the zeros in front would count. So all of those are 3 significant digits. And then bringing forward some of the stuff that I said earlier, remember it's very uncommon for a measurement to end in 0. So if you look at all of these, there's only one measurement that ends in 0. And that 0 is significant because of rule number 4 from the front page. The 0 is after a decimal place. It's a fair bit after, but it is after the decimal place, and it's after other digits that are already significant. So 1, 2, 3. Then, that's technically a hint for later, but for what we need right now, there are 4 significant digits in cylinder B. Okay, and then when we go to find the percent error for the measurement, because it's harder to measure with the ruler, it's just not going to work as well, then there's a certain procedure that we want to see. That formula is on the previous page, so I will zoom back up again, and here we go. What I want you to notice here is that the answer that we accept to be correct, the one that we trust, is used twice. So when you go to set this up, a really big clue for what's going to happen here, We're going to have absolute value because we don't care about the direction. We don't care if it's positive or negative. We just want to know how much is it off. But the given length, there's a label that you can't see, has these numbers on them. So 1.586, then minus whatever you decide is the measured length. That's going to find the difference. Then to go from the difference to percent, then we want to divide, and we use that given number again, so 1.586. So notice the number we trust as the answer we see multiple times. The number that we're checking, the one that we're unsure about, we only see once. So far, subtracting, we got a difference, then we divide. Technically, we find a decimal in that part, but in the end, we multiply by 100 to scale it into a percent. If you're following along on your calculator, and if your calculator happens to have a percent button, please don't use it because it will give you weird answers. Okay, so that should help you set up that one. Make sure you're looking for the absolute value bars and make sure the correct answer is repeated in here twice. Okay, so I'm not going to help you finish that answer. I think that's something you can type in your calculator. The last thing you probably do have to be careful about, make sure either you use parentheses or when you do the subtraction that you hit enter to do that part first, because if you try to type this all the way through all at once, a lot of times your calculator is going to change the order of operations from what you're intending. Okay, and then we would move on and we would basically do all of the same stuff again for our second object. If we look at the second object, that's the second picture, and this is a disk. It's zoomed in, we're looking at the thickness of it, basically the skinny way across, which was in the instructions. And this gets slightly cut off. We can't technically see where the 1 would be. It's somewhere, I don't know, it'd be roughly here. But we can count these lines. We can see or assume that this would be 0, so technically 0.00 centimeters here. Then the slightly longer line, 0.50 centimeters, and then this line would be 0.60 centimeters. Sorry, I'm going to fix my handwriting there. And then the next line, 0.70 centimeters. Like I said before, a lot of times it helps to think about money, right? So this looks like 60 cents, next line looks like 70 cents. And where this object hits the ruler, where the pink line is drawn in, that's just a hair past where 60 would be. So keep that in mind. It helps you to kind of cheat up your answer. As far as giving this a name, this was the 4th disk in our set. And so if we look, if we were looking for the 4th disk, I think there's a pretty obvious name that can go along with that one. Okay, but then from there, you take over, you do the same steps that we did in the other set, eventually culminating in finding another percent error, which hopefully isn't too bad, and then the lab should be complete.